All right, this video is going to be on acid-base indicators. Now, what an acid-base indicator is, it's typically a weak organic acid or base that has characteristic colors or characteristic color change depending on the pH of a solution. All right. So here's a general format for HIN, ion being indicator. General rule of thumb, if the protonated form, HIN, the ratio of that over the conjugate form, that ion minus, is greater than 10, the color of the acidic form predominates. Now, if that ratio of protonated indicator over its conjugate is less than 10, the color of the conjugate base is going to predominate. All right, so here's some common indicators that we use. Now, what's different about these is that they have different endpoints. What an endpoint is, it's a point at which an indicator changes color. Now, this is not necessarily the same as the equivalence point in a titration. The equivalence point in a titration, once again, is when the amount of hydroxide is equal to the amount of H+, or hydronium ions. So it's important to pick an indicator in which the endpoint corresponds to the equivalence point. Now, the equivalence point will be at different pHs depending on the type of titration that you have, whether it be a titration with a weak acid and a strong base, a strong acid and a strong base, or a weak base and a strong acid. So one common type of indicator is red cabbage extract. This is really useful because it has a variety of endpoint colors depending on the pH. So let's look at a titration curve of a strong acid and a strong base in this case. Now, what you're going to want to do with an indicator is the general shape of a titration curve. As you add one known substance to the unknown substance, you're going to see a rapid shift in pH. Now, within that rapid shift, you're going to see the equivalence point. So in this case, the two suitable indicators would be phenolphthalein and methyl red because their endpoints are close to the equivalence point of pH 7 of a strong acid-base titration. Now let's go ahead and let's look through a couple of examples in which we have to pick a suitable indicator for our particular titration. Now, looking at this titration of a base against an unknown acid, I'm going to see that it's a strong titration because the equivalence point is around a pH of 7. So this upward shift, right, this point in the graph, we can see lies between pH of 3 and a pH of roughly, I'll say roughly 10. Right? Oh, they said 4 to 10. All right. So acceptable indicators would be everything except thymol blue, bromophenol blue, methyl orange. Everything except them will be suitable for use in this titration. You can see that the endpoints of everything except those lie within the range that the equivalence point exists. Now let's look at another figure, figure 16.5. All right, this is another titration. You can tell that this is a titration of a weak acid and a strong base. How do I know that? I can see its equivalence point, which lies in the middle of this upward spike in pH in the titration. I can tell that it's that type of titration because the equivalence point is a basic pH. You can see a pH of about 8.72 here. Now let's find a indicator in which its endpoint range is somewhere between, let's say, 6, 7, and 10. All right, somewhere between that range. So the steep portion of the curve. Now that steep portion always contains the equivalence point. That pH is between 7 and 10, so suitable indicators are cresol red and phenolphthalein. Now these are from a table in your book. You'll be given values on any assessment, so you're not going to have to memorize the pH ranges of each of the indicators, but you do not have to know how to use them. So let's look at this final figure, figure 16.6. This is going to be a titration of a weak base and a strong acid. How do I know this? I can see that the equivalence point, the point at which the number of moles of acid is equal to the number of moles of base, falls at a pH of 5.28. All right, falls at a pH of 5.28. That's because, just going back to our titrations video, the conjugate acid of the weak base is also contributing to some extra H plus concentration. So looking at the range of, let's say, pH 3 to pH 7, right? pH 7, 3 to 7, roughly there. The indicators that would be suitable for this would be bromophenol blue, methyl orange, methyl red, and chlorophenol blue.